Hi everyone, welcome to a quick video now, just talking about something that we mentioned at the end of the last video. And this was this idea of solving simultaneous equations, but once we do this substitution thing, applying the quadratic formula in order to find the solutions for the points of intersection. So just working with one question here, hopefully it'll be pretty quick fire because we're just going over something we've already talked about slightly, but we have these two equations here. Now we have the equation of a parabola here and the equation of a line. And we are trying to see, where do these cross? How many times do they intersect one another? Okay, now what we're going to do, since we have a parabola and a line, it can either intersect at 2 points, at 1 point, or at 0 points. But at both of these particular points, anytime we do have some kind of intersection, then our x values and y values are the same. So we've talked about this at length before. Now, since these y values are the same, that means that these guys here are the same. So we can set them as equal to each other so that we eliminate or substitute in something for these y's. So that just gives us an equation that's relatively easy to solve. Or easier now, I should say. Okay. So this is our, whoops, that's meant to be a minus 5. This is how we've laid this out. We've set the y's to be equal to each other, so therefore x squared plus 5x minus 5 is going to be equal to 2x. And now we just want to get this to standard form. So we want everything on one side with a 0 here on the right. Now, 5x minus 2x, that gives me 3x. So I get positive 3x minus 5 equals to 0. Now we have a quadratic equation that we can solve. Now, with this, we could try to do our PSF method, our product sum factor, to use the null factor law. But we can see that there are no numbers that multiply to give me negative 5, but add to give me positive 3. You can try this with the different factors, but this will actually not work. So when we get here, we need another way. So we're going to use my quadratic formula, which is that the solutions to x will be equal to negative b. Remember, the a, b, and c are these values here. Now, if we just have x squared, we assume that the coefficient of that is going to be 1. So we have minus b plus or minus the square root of b squared minus 4ac all over 2a. And now we just want to substitute a, b, and c into my quadratic formula. So I'm going to have minus, my b is 3 here, so I have minus 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 5. And this is all over 2 times 1, because a here is 1. Okay, now that we get this, we have negative 3 plus or minus the square root of 9 plus 20 over 2. And this is going to simplify to negative 3 plus or minus the square root of 29 over 2. Okay, so this is obviously a surd, so we're not going to get a very nice answer, but in this question, the book I'm reading from says to round the values to 2 decimal places. So one of these solutions is going to be negative 3 plus root 29 over 2. And the other one is going to be negative 3 minus root 29 over 2. And those two decimal places are going to be x equals 1.19 and x equals to minus 4.19. And now we have we have shown here that we have two intersection points. I have two values of x where this parabola and my line intersect. Now that I have these, I can just substitute these back into one of my equations in order to get the value for y. And now here we have a pretty clear path of least resistance. It's pretty annoying to substitute this back into the quadratic. Let's substitute this x value back into this equation 2 to find a value for y. Okay, so we're going to substitute sub x equals 1.19 and negative 4.19 in equation 2. So doing this, we are going to get for this value here, well, I have y equals to 2 times 1.19, and subbing in my second x value, I get a value of y being 2 times minus 4.19. And here I'm going to get to 2 decimal places, 2.39. If I use that exact value, I've rounded this, but using that exact value gives me this and gives me this here. So these are my 2 points. So the points of intersection are going to be this x value, this y value, and this x value, this y value. So I have 1.19, 2.39, and negative 4.19, 8.39. So this is how we can use the quadratic formula. And we remember that the quadratic formula is useful when there's no immediately obvious way we can solve the quadratic equation. For example, this one here, after doing our substitution for our simultaneous equations. Here we can't use our PSF method or my null factor law. It's not immediately obvious what that's going to be, but we can always go back to our quadratic formula in order to find first the values for x and then substituting these in to give us values of y. But that brings us to the end of the video. Thank you so much for watching, and I will see you next time.